Okay, today we are going to discuss about the remaining parts of the chapter carbon and its compound. Now, today our main focus on our topic will be the saturated and unsaturated carbon compounds, chain hydrocarbons, branch hydrocarbons, and ring hydrocarbons. Now, at first, we are going to discuss about the saturated and unsaturated hydrocarbons. Okay. Now, question may arise that what are hydrocarbons? Then we can see a hydrocarbon is an organic chemical compound composed exclusively of hydrogen and carbon atoms. Okay, the definition. Now, if we look at the properties, properties of the hydrocarbons, then we can see find that hydrocarbons are highly combustible, producing carbon dioxide, water, and heat when burned. Okay. Now see, these are the examples of saturated hydrocarbons. If we look at the structures of the examples, then we can see the bonds between the atoms. See bonds between carbon and carbon. Okay, carbon and hydrogen. Then we can see that the all bonds are single bond. Now see definition. If valencies of all the atoms of hydrocarbon compounds are satisfied by single bonds between them, such carbon compounds are called saturated compounds. Saturated hydrocarbons compounds, carbon compounds. Okay. Now let's discuss about the unsaturated hydrocarbons. Okay. Now look at the examples. Here you can see here exists triple bond. Okay. Here exists also a triple bond. Now see these are also the examples of unsaturated hydrocarbons. Now its name is ethene, its name is propene. Now here you can see here exists a double bond, here exists a double bond also. So see, such compounds of carbon having double or triple bonds between the carbon atoms are known as unsaturated carbon compounds or unsaturated hydrocarbons. Okay. Now we are going to draw the structure of hydrocarbons. Okay. To draw the structure of hydrocarbons, we have to follow some steps, simple steps. See, first step, is we have to link the carbon atoms together with a single bond. First, we have to join the carbon atoms by single bonds. Next, count the remaining unsatisfied valencies of carbon atoms. Next, third step, calculate valencies which can be satisfied by hydrogen. If all valencies can be satisfied, then use hydrogen atoms to satisfy the remaining valency. That is, if in this step the total unsatisfied valency will be equal to the hydrogen atom, then we can fill the valencies by hydrogen atoms. Okay. Now the fourth step, if valencies per carbon atoms remain unsatisfied, then can be satisfied by using double or triple bond between the carbon atoms. Okay. Now we are going to apply these steps in this compounds. So first join its name is ethane and its chemical formula is C2H2. Okay. First connect the carbon atoms by single bonds. Okay. Now we can see that there are 3 unsatisfied valencies against one carbon atom. Okay, 3 unsatisfied valencies against one carbon atom. Okay, that is total 6 unsatisfied valencies. Okay. Now we can see if we look at the chemical formula, then we can see that there exists 6 hydrogen. Okay, which can satisfy the remaining valencies of the carbon atoms. So we can fill here exists 6 unsatisfied valency, and there also exists 6 hydrogen. Okay, so we can fill the unsatisfied valencies by hydrogen. Okay, now here you can see this is the structure of ethane. Okay, now we are going to discuss about another group. We are going to draw another structure which name is ethene. Okay, its chemical formula is C2H4. Now see, first we are going to connect the 2 carbon atoms by single bonds. Now we can see that there are also 6 unsatisfied vacancies. 3 4 is carbon. Now if we look at the chemical formula, then we can see there are only 4 hydrogen which can satisfy only 4 unsatisfied valencies out of the 6. Okay, see, here are 6 unsatisfied valencies. Okay, but here present only 4 hydrogen. So now what we can do? Well, can we satisfy the valencies by putting double bond on triple bond? Let's see. Okay, if we put double bond between the carbon atoms, then we can see the remaining valencies will be 4. 2 against is carbon. Now we can see the remaining valencies, unsatisfied valency is 4, and also present 4 hydrogen. So 4 hydrogen can satisfy the remaining unsatisfied valency. So we can fill the unsatisfied valency by these hydrogens. Okay, now this is the structure of ethene. Okay, now let's do another structure. See, its name is ethane. Its chemical formula is C2H2. Now if first we are going to put a single bond between these 2 carbon atoms. See, like above cases, here also exists 6 unsatisfied valency. Okay, now if we look at the formula, then we can see here is only 2 hydrogen. Okay, which can satisfy only 2 unsatisfied valencies out of the 6. So we have to put double bond or triple bond. So if we put double bond, then we can see the remaining valencies will be 4. Okay, here present only 2 hydrogen, so it cannot satisfy the remaining valencies. So we have to put triple bond. Okay, if we put triple bond, then we can see the remaining valency for each carbon will be 1, the total 2. Okay, now we can see that the 2 hydrogen given in the formula can satisfy the remaining unsatisfied valency of carbon. So this is the formula of ethane. Okay, today now we are going to discuss about the straight chain hydrocarbons. Okay, now see, here are the straight as hydrocarbons definition. Now these are the examples. Now these names are very important, and remember all these symbols, structure of the compounds. Okay, this is methane, ethane, propane, butane, pentane, hexane, and so on. So see, hydrocarbons where carbon atoms are connected in one continuous chain with no branches. Okay, these are called straight chain hydrocarbons. Okay, these are the examples. Now see, this is the branch hydrocarbons. Okay, see, branch chain hydrocarbons. See, many hydrocarbons have branches of carbon atoms attached to a chain. They are called branch hydrocarbons. Okay, branch chain hydrocarbons. Now in this example, we can see that this is the main chain. Okay, and here join or link another carbon as a branch. So this example is an example of branch chain hydrocarbon. Okay, now last we are going to last we are going to discuss about the cyclic hydrocarbons. Okay, cyclic hydrocarbons. Now see, a cyclic hydrocarbon is a compound composed only of carbon and hydrogen that forms a ring. Okay, here the hydrogen and carbon forms a shape like rings. Now here we can see that here if we look at it, here present 6 carbon, okay, and total 12 hydrogen. If we look that the 6 carbon and 12 hydrogen make a circle type shape, so we can say that this is a cyclic, okay, cyclic compound, so it's called the cyclic hydrocarbons. Okay, now let's draw another cyclic hydrocarbon. Its name is cyclopentane. Okay, its formula will be C5H10. Okay, C5H10. See, carbon 5 carbon atoms, cyclopentane. It will make a circle like shape. Okay, now these are the 5 carbons and these are the remaining valencies which can be satisfied by the 10 hydrogen given in the formula of cyclopentane. Okay, thank you.